Hi there, and welcome to another video lecture for the Digital Methods course. Today we will be analyzing, more specifically visualizing, some data in Power BI. I had to pick some kind of case study, and since we're living in exceptional times, namely Corona times, I tried to analyze the spread of the COVID-19 virus across the globe in what we call a dashboard in Power BI. A dashboard is basically a collection of visuals which are interactive, so people can compare countries, for example, when it comes to their success in battling the crisis, for example. And I combined some data sources. I did some data wrangling so I can provide you guys with a clean and usable data file that you could analyze in Power BI. So as always, let's see where this fits within the general framework for this course. It's a good idea to watch this around the time that you've handed in your proposal for the data wrangling of your exercise, because this workshop is all about data analysis. So you could use this workshop to actually provide the analysis that you will hand in on the 4th of May. Of course, creating some visuals is not the same as creating a statistical model in SPSS, R, or Python. But still, visuals could serve the purpose of actually extracting information from data. It creates an overview. You can check certain correlations, relationships, and even interactions if you want. So this course is also intended for everyone, since everyone should do a data analysis at the end of their exercise. Okay. Now, a very short preview on what you're about to learn. So what I did is I made a dashboard. Again, a dashboard is a collection of visuals, possibly on multiple pages in Power BI, that are or are not interactive in nature. As you can see here, I worked with data from the 24th of March. So I have information on the spread of the coronavirus up until the 23rd of March 2020. So, for example, this is one pane, or let's say page, of the dashboard, which provides a general overview. So you can see here the number of total cases in the world and the number of recovered and deceased individuals. Now, what is pretty neat about these Power BI visuals or dashboards is that they can be interactive. So I can click on any of these countries here. For example, let's take Belgium and click on it. I can see that all the visuals on the page adjust themselves to only include Belgian data. I can even pick more than one country, so I can click on Belgium and the Netherlands. There you go. And it will add the numbers of these two countries together. Now, there you go. I also made a page to compare different countries. So again, these are some interesting graphs that plot on the x-axis always the day since 100 cases have been reported in a certain country. This is a really important variable in the data set because otherwise we can't compare countries. Because in Belgium, for example, the first 100 cases were, I think, around the 18th of March. Then we had 100 people infected with the corona, or anyway reported. But in the Netherlands, it's on a later date. But if we create a variable for each and every country that puts the day with at least 100 cases as day number 1, then we can just put these graphs together and see how they compare. So let's compare, for example, this is Belgium here I selected. Let's compare Belgium with the Netherlands again. There you go. Now you see that the graphs adjust themselves. You can see that the infections per million inhabitants are about the same for the Netherlands and Belgium. However, the deaths per million inhabitants, there you can see that the Netherlands performs a little bit worse than Belgium. And that they score a little bit higher, especially the last couple of days. You can see here, the fifth graph, also the growth rate of the cases by day. And then this is another interesting page. So I correlated some characteristics of a specific country with the number of infections per million inhabitants on the 23rd of March. So every dot is a country. If you hover over a dot, you can see the country. So this is Norway, this is Andorra, etc. Right? For example, you can see here very clearly that the more a government spends on healthcare in percentage of the total expenditure of healthcare in a given country, so the more a government invests in healthcare, the more cases get reported. There is a very clear positive correlation. The question, of course, is it a causational or not? This is something we don't know. This is just a correlation. You can again just pick a specific continent here, a region, and then just the graphs will adjust themselves. You can also select graphs by their GDP. So this is the graph for relatively poor countries, and this is the graph for relatively rich countries, right? You can combine them. So, for example, African relatively rich countries. Then these are the relationships. I have a couple of other pages, but these are the three most important ones. And we'll create a couple of them. We'll see how quick we speed through this, but we will create at least 2 of these pages. Now, before we go on, let's have a look at the data first, right? Because if you don't understand the data, you don't know what the data is, how it looks like, how it's structured, then it's very difficult to know how you can visualize the data at all. So I combined multiple data sets for creating this dashboard. The first one is the most important one. It's from the Johns Hopkins University, and it reports every day an update with the number of infected people, the number of deceased, and the number of recovered people in separate data sets though. And then I scraped 3 other data sets that contained metadata basically on a certain country. For example, what is the population density? What is the total population? What is the median age in a given country? That is something that the Worldometer website gave me. I also got some data from WHO, the World Health Organization, when it came to statistics on the health spending from certain countries. For example, the variable I just talked about, the percentage government expenditure on healthcare, is something that came from the WHO. And then I also scraped a very simple table that divided countries by their continent. And this is the reason why we could select a specific continent in one of the pages on the dashboard earlier. Together when I joined all these data sets, I could create the dashboard here. Okay, so this is where you can find all the data sets. 2 of the 4 data sets here I just obtained using the Power BI web scraper menu. So it's basically, again, let's see, if you click on in Power BI on new source and then web, you can just fill in a URL, and if this URL contains a table tag, you can just scrape it directly from the website. There you go. And the other 2 data sets, one of Johns Hopkins and the other from WHO, I just downloaded manually and loaded them into Power BI. So this is what I've done. So very short, I joined the 3 data sets of Johns Hopkins on the cases, deaths, and recovered individuals of the corona crisis by country and by date. I also took the metadata from the other sources. I joined them as well, and I changed the country names if necessary. For example, let's take the country, the Democratic Republic of Congo, is sometimes denoted as simply DR Congo. So these different spellings is something that is a bit of a hassle, gives you a little bit of trouble when you want to join data sets on countries, when the country is ID basically. And then I joined these 4 data sets, or actually then 2 data sets, one Johns Hopkins and the other one just a meta data set on different countries. I joined these 2 data sets, and then I calculated some extra measures such as the growth rate, some standardized metrics such as the number of infections per million inhabitants, which is something I showed you earlier in the dashboard. And also I checked whether this was a particular day where there were more than 100 cases in a certain country or more than 1,000 cases. And I also counted those days from 1 until whatever date we are now. Okay. You can find the result of these wrangling operations only for that. So this is the result of my work here, let's say. You can just load this file into Power BI and create some visuals right off the bat. Now, I also included the raw data sets that I used to come up with the wrangle data set. You don't need those for this exercise, but it's obviously a good idea to try to come up with the wrangle data set based on these 1, 2, 3, 4, 5 data sets. Of course, it doesn't include the worldometer data sets, which were scraped simply by using the web menu in Power BI, again, which I showed you earlier. Now, just to have a grasp of what the dataset looks like, this is the original dataset from the Johns Hopkins University, and there you can see that each and every line represents one country or one region of a country. For example, as you can see here, Australia reports their cases by province or state. And this is something that we don't want. We want just one line for Australia. We want all the data summed for Australia because our metadata is about countries and we don't have specific metadata of provinces and states. So we just want to do a country-based analysis or country-level analysis. You can see here, and this is very important, that each and every day is a separate variable. So if you look here, Afghanistan, right, you can see that on, let's see, there you go, the 24th of February, they have their first case. And of course, the last variable is, no, this is not the right, there you go, is 23rd of March. Right, this is our last day in our data set. So again, one line is one country or one region. In the wrangle data set, this is totally different. In the wrangle data set, one line represents one specific day in one country. And moreover, we have in the same data set the number of deaths, the number of recovered individuals, and the number of infected people, and not separate as in the Johns Hopkins dataset. For example, in this dataset right here, it's all about the number of cases. You can't find any info on the number of recovered and the number of deceased people. You can here. So one line is one day in one specific country. You can see here, let's go to Belgium, Control F. You can see here the situation for Belgium. We have our first case here on the 4th of February. And you can see that we have 100 cases from the 6th of March. The variables in blue here are all variables that I calculated. A couple of important calculations are the number of infections per million inhabitants, again by day, so this changes this metric by day, or could change if there are extra people infected. Also, this is a very important variable, 100 cases. So this is an indicator variable that says that this is a day where in a country, certain country, at least 100 cases are reported. So this is one from the 6th of March onwards in Belgium. And then in the variable next to that, I count these days. So 1, 2, 3, 4, etc. until the 23rd. As you can see, the 23rd of March. So this is a very important variable if you want to compare the countries with each other. I want to plot a graph to see how cases grow from the day that 100 cases were reported. I also calculated the growth rate, as you can see here, also changes by day. And then you have a couple of variables that I scraped from the web. So the population of Belgium, 11 million, and then some. As you can see here, for all the rows belonging to a specific country, this just is the same variable, the same value. It gets copy pasted a couple of times. So these are 62 times the population of Belgium. Then we have the population density in Belgium, the median age in Belgium, or the number of percentage of people, but here in proportion, or expressed in a proportion, that live in urban area. So according to the WHO, which is where the data is originally from, 98% almost everyone in Belgium lives in an urban area, the continent, and then here, this is also a pretty important variable. So if you take the entire expenditure on healthcare in a given country, then this variable represents a percentage that is provided by government schemes or programs that are mandatory. So this is basically Bernie Sanders, his dream. This is a sort of socialized kind of medicine scheme, something that we have in Belgium here. So this is why the percentage here is pretty high, 77%. And then we have, these are some other streams of financing the healthcare in a given country. For example, the out-of-pocket spending is just basically if you're having trouble, if you need to go to the hospital, you need to pay everything out of pocket, just your own money. So it's pretty interesting to see whether these variables correlate with, for example, how fast a given disease such as COVID-19 spreads in a given country. And then we have also the GDP. Actually, it's not GDP, but it's measured by the PPP index, which is basically a way, something that economists came up with, a way to standardize the GDP so we can compare rich versus rather poor countries with a standardized metric here. Also, again, to see whether this might have an influence. So all these variables, you have 3 categories. One category, the Johns Hopkins variables, the number of cases, deceased, recovered. My own calculations based on these figures, just as the growth, like the growth rate, for example. And then we have the metadata country level variables that are specifying, for example, the median age in a given country or how they organize their healthcare. With the help of these 3 categories, we can make some interesting visuals that could lay bare some pretty remarkable patterns. So again, these are the variables here. We saw these in the dataset. Now, before we actually start, some general advice and a couple of caveats as well. So 3 key insights for success when it comes to data visualization is first that analyzing also includes a little bit of data wrangling. So I know that you hate data wrangling probably. Everyone hates data wrangling. It's universal. And although you have a somewhat of a clear idea in the data wrangling phase how you should transform your data so you have a workable data set, still there are some special visuals that require you to summarize a table, to pivot a specific table, unpivot it, to group it, to create some certain statistic that you haven't, come up with during the data wrangling phase, etc. So these phases are not, the data wrangling and the data visualization phase are not entirely separate from one another. Second is that visualizing is basically creating an overview of the data. So you zoom out instead of zooming in. This means that we will focus on detecting general trends, difference in these general trends. For example, when it comes to the coronavirus data, we will see whether certain trends between countries differ or not. For example, are the Netherlands more successful in battling the coronavirus than Belgium, for example? And use the dynamic nature also of these dashboards, of these visuals in Power BI, to check for certain interactions or hypotheses. For example, is there a relationship between how a given country organizes their healthcare system? For example, a lot of government expenditure in the healthcare system, and whether this has an impact on, or let's say, a correlation with the number of infected individuals per million inhabitants. Is there a relationship there? And if this is this relationship the same for every continent? Is this the same in Africa or in Europe or whatever? And a third trick, let's say, and this is the most important one. The most important thing here is that you should just try something out. I haven't followed the tutorial to create these dashboards. I haven't read anything about Power BI. I just clicked on stuff. This is my basic advice. Just click on stuff and see what happens when you fill in a certain option, when you fill in a certain filter in Power BI. Just see what happens, and then you get the hang of it. And also don't give up, right? And always think about, your tricks in your toolbox. For example, maybe you should create a new data set. Maybe you should summarize data set. Maybe you should create a sum of a certain variable and plot that instead of just plotting the raw data in a visual. So be experimental here. This is my basic advice. Then two important caveats before we start. First of all, I'm not an epidemiologist, and I believe you're not one either. And making fancy visuals doesn't make you one as well. So this is something that you see in the last couple of weeks, that since the coronavirus outbreak, that a lot of people who are kind of okay with, dealing with data, visualizing some data, collecting some data, that they share their visuals on the web and they take some very grand conclusions away from these visuals. Please don't do that, because epidemiology is a serious field of study. It takes years to be trained in this subfield or in this field. So whatever we may conclude from our visuals from today, know that we don't know what we're talking about, right? So this is pretty important to take in mind. A second caveat here is that correlation doesn't mean there's causation. You know that, but this is especially relevant in this case. For example, maybe we find that as the number of elderly people in a given country increases, that the number of infected in a said country increases as well. Well, it could be that this is a true relationship, that countries with many elderly people are more prone to a very fast and maybe even deadly spread of the virus. But it could also be a spurious relationship based on coincidence. For example, Italy is, one of, or basically the country where the outbreak started for Europe. And it also happens to be a country with a high percentage of elderly people. So if you find a relationship, is it because, there's really something going on with these numbers of elderly people in a given country and the number of infected? Or maybe it's just because Italy happens to be a country with a lot of elderly people. It's really hard to find the causational evidence here. Okay, so let's finally start and create the dashboard. So open Ufora and download the wrangled dataset in the Practical 5 folder of the practicals. Okay, download it. I already did that. And open up Power BI. Now, if you open up Power BI and want to load in some data, it's a good idea to go to Transform Data if you have an older version of Power BI, or if you work from Athena, Then this will be at the query editor. So click on that. And then import a new source. Our file is a CSV file. And import it. So you know the drill. UTF-8 is the file origin. semicolon seems like a good guess of Power BI for the delimiter. So that's okay. And we load the data. There you go. So again, this is the Wrangle data set that I created for you already, where one line corresponds to one specific day in one specific country. Okay. Now, this here, the query editor, this is something that you know from the data wrangling workshop from Frederik. This is where the hard work, let's say, takes place. This is where you create new variables, where you filter certain variables, where you do a group by and you summarize data, you join data, etc. And this is also the page, let's say, or the part of Power BI where you determine your variable types. And this is not so important in the first place when you consider the data wrangling phase, but in the data visualization phase, it will be pretty important because if you want to display a number, we have to make sure that the data type is also set to number. So let's review the variables here. Decimal okay, all okay. So this is a decimal number, as you can see. If it's 1.2, 1.2, yes. 100 cases, 1,000 cases, yes. Okay. These seem good until we have here the median age in a given country. Again, this is copy pasted around 62 times since we have 62 days under study here in our data set for each and every country. So Afghanistan is definitely a very young country, median age 18. But it's set as a text, and this will give us a lot of trouble when we want to visualize it, because you can't use this for your x-axis in a scatter plot, for example, right? Because it's a text and it's not interpreted as a number. Why is this the case? So if you check and load all the values of the variable, you can see that missings are indicated by NA. This is again the WHO dataset. So we want to replace the NA with the corresponding missing value in Power BI. And this is null. So if you indicate a value as null, then Power BI will interpret it not as a piece of text, but as a missing, right? This is a standard form of indicating a missing. So right mouse click on the median age. Let's say that we want to change this to a whole number, median age. There you go. Now it will give you some errors. So if you scroll down a little bit, you'll see that, there we go. For some countries we don't have the median age, in this case Andorra, for some strange reason. And what we want to do is we want to replace these errors, which are actually NA values, with null. So again, right mouse click on median age, click on replace errors, because we want to replace the errors, and these are null values, these are missings. And there you go, now we don't have any errors anymore. There you go, Andorra null. Okay, so these are numbers, fine. Let's check the rest of the variables. These should be numbers as well. Let's do decimal number. Okay, no errors. No. And then GDP measured by PPP index, also a decimal number. Good. Okay. The data types are good. This is pretty important before you start analyzing your data. Okay, now we close our query editor. And now we load our data set into the visualization part of Power BI. And you can see here that Power BI just loaded our data set here, Wrangle data set, with the corresponding variables. Now what you see here in the middle is a visualization selection tab. Here you can see all types of visualizations that you can do, such as a scatter plot, which is here, which is a classic, some bar charts, a line graph, as you can see here, a line chart. Beneath that, you see all kinds of options that you can fill in and that you will fill in for a specific chart. So this part changes whenever you're selecting a specific visual. And this here, next to that, on your left, you have a filters tab, let's say. And it's also pretty important. So you can add a filter on a page. This means that, for example, let's say we only want to display data on European countries. We can just, drag and drop continent here. So just hold it with your mouse and then just release it. There you go. And then we can say, okay, we only want data on European countries here. And on this page, on this entire page, whatever visual we create here. And then it will only display data of Europe. And you will also see that you can filter the data in a specific visual, right? So that each and every visual, for example, one visual about Africa, one visual about Europe, is also something that will pop up whenever you add a visual. Okay. So now let's actually add a visual. Let's do a line chart here. There you go. I can see here immediately that the filters on this visual part of the filter tab pops up here. Okay. So what we want to do now is give a general overview of the amount of infected people, not deceased, not recovered, but infected people around the globe. Okay, so you can see if we select the visual here, then we have all kinds of options here. The axis is your x-axis, so we want the date, obviously, on our x-axis. No, sorry. There you go. Then we have the values. This will be our y-axis. In this case, the number of cases here. Okay. But imagine that we also want the amount of deceased as a separate line. Yeah, we can add this in y2. Okay. Now I can see you only see 2 dots here. This is because, and this is really, really, really important, that you always check what the visual is displaying here. So when it comes to cases, it displays, you just click right over here, it displays a sum. You can also display an average, a minimum, a maximum, and so on and so on. Okay. When it comes to the date, it displays it as a date hierarchy. And so it displays only the year. So when you delete this, year, and then quarter, then you have the month. Now you can see already we have 3 months in our data set from January 22nd until 23rd of March. You can see 3 values. And then day, which doesn't make sense because we have some days that are, for example, we have both the 20th of February and the 20th of March in our data set. So the days don't refer to a specific day here. You can solve this simply by selecting date instead of date hierarchy. So right now, there you go. It displays the dates specifically here. Okay, cool. Now imagine that we want to also display the amount of recovered people. If we want to do that, we have some trouble here because there's no Y3 here. And this is because our data is not formatted appropriately for this type of visual, or basically for any visual. And it's also one of the most important lessons you will learn in this workshop. So let's go back to our query editor and click on Transform Data. So the main issue here, or problem, is that we want to plot 3 variables and not 1. And this is why melting data or unpivoting data, whatever you want to call it, and apply a filter to a visual is one of the key insights that you could gather from this workshop. So we'll just select our 3 variables that we would like to plot on our visual. And then go to Transform and select Unpivot Only Selected Columns in the Transform tab. There you go. Now, a couple of years ago, I worked for a company and I did the data analysis, but sometimes I had to deliver some data to our data visualization specialist. Whenever I had to do that, I had to make sure that I delivered the data as such. Namely, that I have one column with basically all the values that you want to plot in a single graph. And next to that column, the attributes, or basically the categories that belong to a certain value. And this is what we have here. So we basically tripled our data set, right? So instead of one row means one day in a particular country, we now have 3 rows for each and every day. So I'll just send this, I'll select this, and in transform, I will move this to the beginning. There you go. As you can see here, Afghanistan, the 22nd of January, we now have 3 values, one for deaths, one for the recovered, and one for the cases. So we tripled our data set, right? Instead of one day means one row in one country, we now have 3 rows for one day in a country. And this is a very important trick here. This is what they call melting data, because you basically create one row per column, and you could see it as literally melting your data in a longer format. Or you could just call it unpivoting, whatever you want. Okay, let's call the attribute type here, as in type of value, that's recovered cases. And click apply. Okay, so this doesn't work anymore, which makes sense because we unpivoted or melted our 3 columns. So select the visual again and delete the values. And y2 is also something that we don't need. And now we basically have one variable that we need to plot, right? We need to plot the value. So drag and drop the value variable here. And always make sure what kind of function that you're applying here, so we make a sum. Okay, cool. Now, you might be wondering, okay, Christoph, this sounds really neat, but these are the wrong values we want to plot. Because right now, when you do a sum, each and every day of the value variable, we sum the cases with the deceased and with the recovered individuals. And this is true, right? So if you want a line, let's say, for each and every type, well, we can just add that to the legend here. Right? So if these are our labels, the type, remember, the deceased, the cases, and the recovered. Drag and drop that into the legend. And there you go. Now you have 3 graphs. Okay, again, you might say, this is pretty neat, but imagine that I only want to plot the number of cases in one single graph and not the deaths and the deceased individuals and the recovered individuals. Okay, that's fine. So do away with legend. I will just click this away. With legend, there you go. And now you can basically filter this visual based on the type. So I drag and drop the filter on this visual here, and I just select the cases. There you go. You see the difference? If you select everything and select only the cases. So these are only the cases, basically a sum of all the cases on a particular day. Now, this is also one of the main tips and tricks I give you. Always be aware of the function you're applying to any variable in Power BI. So we take a sum here for each and every day for only the rows, let's say, that are indicated as cases. Does this make sense, or are we summing too many values? Is this the right function to apply to? Maybe we have to do a maximum or whatever. Okay, let's reflect on that. So let's go back to our query editor for a while. There you go. And let's basically filter and type the cases just for now. Okay, so if we take a sum of cases for any given date, so let's select any given date, the 22nd of January, for example. Okay. If we sum the values and then we filter on type and we plot 1 point for every date, right? Because this is our x-axis, the date. And basically, the value on the 22nd of January should be 1. There's 1 there. And then we have 548 in China cases on the 22nd of January. So it should be 550, right? Is this true? Yeah, 555, whatever. I missed a couple, but in essence, that's correct. Now what we do here, what we sum, is basically we sum over all regions, right? So we sum each and every case in every region. And this is exactly what we want. So this is the correct function to apply. Now always be aware what function you're applying, what does it mean? What does it mean to take, for example, a maximum here? So if we say, first of all, let's undo all these filtering operations because this will have an impact, of course, on the data we work with. So click delete the filtered rows applied steps here. Okay. We can just, again, close and apply, although we didn't apply anything. There we go. So if we click again on values and we take a maximum, for example, well, then you can see totally different values here. So what does it mean to plot the maximum for each and every date? Well, it means that the country with the most amount of cases basically gets plotted, its value gets plotted. And you can see here, this probably, yeah, I think this is basically the value for China we're always plotting, right? Which is kind of stabilized over the course in March 2020 when it comes to the cases, as you can see. But we want to have a sum. We want to sum all values in all countries, so we have a global indicator of the spread of COVID-19. So again, tip and trick number 2 after the melting and filtering trick is always be aware of the function you're applying. Okay. Now this looks okay. Let's see if we can make it a little bit prettier. So let's go to our format options. Data colors, let's make it a kind of grayish color. That's better. The x-axis, fine. Actually, I'm not really satisfied with the x-axis, namely because the real outbreak, especially in Europe, started in March, let's say. So let's only plot the values in March. Again, you can just apply a filter to the visual. So go to filters on this visual and click on date. And you can do an advanced filtering. So advanced filtering is after the last day of February 29th, in this case. There you go. This already looks a little bit prettier because you zoom in on the most, let's say, relevant part of the graph. But I'm not really satisfied with these labels here. Now, since we're working with days in March, we could apply just a date hierarchy instead of the specific date on the x-axis. So again, go to date axis and click on date hierarchy. And then again, we have the issue that it just plots the value of the year 2020, which is one value. Delete year, delete quarter, delete month, and there you go. Now the x-axis represents the day number, excuse me, in March. And this is way prettier because you have this equal spacing between days, right? So 5, 10, 15, 20 is better. Okay, so again, go to the format. X-axis looks okay. Y-axis looks okay as well. This is something I always do. I just open up each and every option that I have, and I just really manually check whatever I need to or want to adjust to make the graph more informative and or prettier. Data labels, yeah, you could, if you check this here, you can basically display all the labels. So on the 10th of March, we had 118,000 cases, but we don't want that. It's okay. The shapes, let's make the line a little bit thicker. There you go. The title, obviously, let's give it a title. Cases plotted since 1st of March. Okay, cool. Let's put this in the middle here, this title, and make it a little bit bigger. You see, this is prettier, more informative, has a nice overview to it. Look, aspect ratio, border. No, we don't want a border. Okay, so this looks okay for our first graph. Let's put this right in the corner. And I want a similar graph that displays the number of deceased and recovered. Let's make these graphs the same size. So I play around with the size a little bit. And I do a layover of the second graph and I just adjust it so it's the same. Oh, excuse me. There you go. So these are the same size. Okay, they just fit barely. Let's make it a little bit. There you go. Okay, better. Okay, again, select the second graph. So you copy pasted also all the settings of the first graph, which is pretty neat because all we need to change here is the filtering. So we don't want the cases to be displayed, but deaths and recovered. Now again, what do we miss here? We miss a legend. So if you drag and drop type into the legend bar here, then the values will be plotted according to the values of the categories present in the legend. And so we have, there you go, a separate graph for the recovered and the deaths. All right. Again, you could add cases to this graph, but we don't want that. We just want the deaths and the recovered. There you go. Now I want the kind of positive-ish color for the recovered. So let's pick a custom color here in the format options. You can pick a color for each and every line. Let's do greenish. Yeah, that's okay. And the deaths should be reddish, negative color. There you go, you see? Okay, great. Now, of course, we want to change the title. So let's say deceased and recovered, plotted since 1st of March. Okay, there you go. Now, what you want to do now is you want to be able to filter this visual according to a specific country. So you can just click on a certain country, for example, Belgium, and the graphs will be updated with the appropriate figures. Well, now there are two ways of doing this. You could add what they call a slicer to your data. But what we do, or what I would like to do, is add a table, which basically serves the same function in most cases, not in all cases. But you can add multiple, let's say, columns with some informative values next to the values you want to plot. So let's make this very concrete. So add the data fields to your table. And in this case, it's a country or region. There you go. Now you see we display each and every country and region, which is one issue we will tackle in just a moment. And we could add, for example, to that, let's do the value. Okay. Now we want not a sum of the value, because if you do that, then, well, sorry. If you do that, for example, we get a value of 5 million in China, but they're not 5 million in China with COVID-19. But this is just because this is a wrong function to apply to our value or variable here. We basically want to display this situation as it is right now in the 23rd, let's say, of March. So this means we have to apply a filter to this specific visual. So drag and drop date on the filter tab here. And just say I want a relative date, and is or not, maybe I want advanced filtering. It's not, it's before, or top N. I want a top N, I guess. So I want a top 1 date by value, and again, date. So again, drag and drop date here. And I want the latest date. There you go. Okay, so this is, again, this does sum the cases and the deceased and the recovered. So let's do another filter. So I don't only want to now have the value of the latest date, the top 1 latest date, but also I want to filter by type. And I want to only, there you go, see the cases. You can see the table values change as I filter on type, the cases. So this displays the cases on the 23rd of March for each and every country. Now you can see here, so there you go, China still has the most cases, 81,000, and then Italy. Whether we take a minimum or a sum or whatever, doesn't really matter here, right? So if you take a maximum, the value for China stays 81,000 when we take a minimum as well, when we take a sum as well. And this is because, thanks to our smart filtering choices here, we just select one value here. So we select for each and every country the latest date, and then only the cases label. And this is just one value, basically. So whether you take a sum or a minimum or a maximum, it doesn't matter here, right? But it's important to know that it doesn't matter, right? That you have an idea of how your filtering options impact the meaning of the functions you apply here. So whatever you want, you can take a minimum, a maximum, a sum, doesn't matter. Okay. Let's call this so you can change sort of the title of your column by clicking on values and change min of value to cases now. Or well, cases on 23rd March, makes more sense. Okay, and then country region should just be region, for example. Oh, there you go. Okay, cool. Now we don't want this total row. So go again to formatting options and go to total and click on it off. There you go. So this is something that looks kind of okay, but the issue is that there are too many countries in this table. Imagine that we only want to display the top 30 countries in the world. Now this is a real issue here. So this is again something that you need the query editor for. So let's go to the query editor. And what we want to do here is we want to add a variable to this data set that indicates the ranking of each and every country, right? So that we can filter our visual on this ranking variable and say, okay, we only want to display the top 30 countries, the cases, or the countries with that are in the top 30 when it comes to the amount of cases right now. But since each and every day represents, or each and every row represents a different day in a certain country here, we need another different data set based on country level and based on the latest date. Now, this is the third important trick, let's say, that I give you in this workshop. And that's that always be aware that you can copy paste your initial data set, that you can apply some functions to the data set. You can filter something, you can rank it, you can add another column, you can group by, very important. You can group a certain data set and some aggregate a couple of variables. And you can add this information to your general data set later on. So let's do just that. So first of all, copy paste the data set. So copy Control-C in Windows, Control-V. There you go. And let's call this data set ranking cases countries. There you go. Okay, so we only have to do some filtering on this data set to obtain the ranking of cases right now for each and every country. So let's be creative here and let's select date, go to date filters and select is latest. So this is the latest date. And then for attributes, we only want the number of cases. We want to do the ranking based on the number of cases and not anything else. There you go. You can just delete all the other variables. So if you hold Control Shift and you go to the end and you select that column, you select all the columns. So again, select one column, go to the end, Control and Shift, and there you go. And just press delete if this works. Yeah, this works. Okay, attribute you can do away with as well. Okay, so now we just have one row for every country here, and the number of cases as of now, the 23rd of March. Okay, so let's rank these because we want a ranking. So do sort descending. And we can see that we have China here, then Italy, United States. This is basically the values that you already saw here, right, in our table visual. And now I want to add a column, namely, since we ranked them from high to low, go to add column and add an index column. And say you want an index column from 1. So it starts from 1. There you go, 1, 2, 3, 4, etc. So this is our ranking variable. That's how easy is it, right? So we were a little bit creative in how we came up with this. We sorted the data set first, and then we just add a ranking, an index column to that. And it happens that, since we sorted it by value, that this index column represents a ranking, right? This is not something inherently an inherent characteristic of an index column. An index column just, creates values from 1 until the end of the data set, but it's a ranking in this case. Okay, now we want to add a ranking to our general data set. Let's go to our general data set here, and you join data sets, and this is something that Frederik probably already talked about in his workshop on data wrangling. Go to merge queries. There you go. And then select our ranking here. And select the 2 ID columns of both data sets. And let's do a left outer join. So a left outer join means that we keep all the rows from the first data set, and we just add whatever matches from the second data set to the first data set. Okay. You can see here that all rows are matched, which makes sense because we just, it's the same column or same values for the countries here in both data sets. And click on OK. Okay, now we have to expand the table. So we only want the ranking basically, and maybe the value, so the current cases. Maybe we want to filter on that on some point. For example, imagine that we want a page that only displays values for countries with at least 100 or 1,000 cases. Well, we can do that by using the value variable from our ranking data set. Okay, so as you can see here, these values are copy-pasted 62 times. Right? Sorry, 62 times 3, since we have tripled our data set with 1 row for deaths, 1 for recovered, 1 for deceased. And let's rename the value column as cases now. So we have 40 cases right now in Afghanistan, as you can see here, all these values. And we have, and Afghanistan is 101 in ranking when it comes to the amount of cases. Okay, great. These are both decimal numbers. It's not necessary, so let's just change it to whole number because of ranking. There you go. Cases now also whole number. That's correct. Okay. Okay, great. Now close and apply. And there you go. We are back with our visualization editor. And I see that the ranking is added to our data set here. Let's click on our table visual and let's apply this filter on our visual here again. There you go. And let's do advanced filtering and say that, well, we only want rows and thus basically countries, because the ranking is based on the country values. We only want values that are less than 31, so the top 30. There you go. And now we have our top 30 countries. Maybe let's do 40, or no, let's do 35. Okay, does this fit on our page? I'm afraid not. Yeah, it does. Okay, cool. Okay, and there you have it. Now you only have your top 30, and you could even add the ranking to your table, so people could see the ranking and even rank the ranking. again. So drag and drop the ranking variable to your values. There you go. Now what we want here is, you can see, there you go. Okay, great. This looks okay. Okay, great. Now you can see the ranking here. People can rank it from low to high. So Greece is number 34 here, or high to low. Okay. Now whenever you select a specific country, you see the specific numbers for that country. So you go to Belgium, and you can see something went wrong here. And this is because we basically, we selected, based on the cases here, this variable here, the top one by latest date. And this means we only get to see the value for the 23rd of March. And that's an issue here. So you have two options. First of all, you could just change the filter here and do away with the filter of date. There you go. But this means that we want to, or have to also apply a different function to our cases value. We don't want a minimum or a maximum, right? Because you have a lot of zeros now here, because there was some point in the data set that most countries had a zero, except China, who already had 548 cases here. Well, you want a maximum. So the maximum value, there you go. And let's see what that gives. Okay, this makes sense. And if we now click on Belgium, we still have an issue with the second graph here. Now, why is that? Well, it's again because we have applied a certain filter to our table here, namely attribute is cases. So let's delete that as well. And now we finally have a correct display of our visual here. Now what I did is, instead of applying all the filters, I replaced this with a simple function of the maximum on the value column. Now, of course, this is only a legitimate way of, creating this type of table, type of visual, when you assume that the maximum value always represents the amount of cases, so that there are no more recovered people than infected people, or no more deceased people than infected people. Then the maximum value on the 23rd of March for a given country represents the amount of cases, right? So of the three, the amount of cases tends to win, let's say, is a maximum value. Okay, so this looks pretty neat. Now we want to display the specific numbers, and you can do this by creating some cards. So click on the card visual here, and we want to display the number of infected, the number of deceased, the number of recovered in total if you don't select a specific country, and for a specific country if you select a certain region. So drag and drop the value fields over here. And again, you can see that the value here is 8 million. And this is just the value when you sum all, basically all recovered, all deceased, all infected on each and every day in all countries, and you have 8 million people. This is obviously not what we want. Here we want to apply some very specific filters, and maybe we should apply some filters on our visual here. So let's see, we only want the latest numbers. So again, go drag and drop date here on this visual and do a top n. I want top n1 of date. So drag and drop date here, and I want the latest date. Okay, there you go. If you do then a sum, then we have basically the sum of cases for all countries, and this seems to be correct here, right? So almost, almost 500,000. But still, we want to only display the cases here, and this means that we have to go back to our type variable here, and again just drop it on the filters on this visual and select cases. So we only include the number of cases and not the number of deaths and recovered. So okay, we have around 400,000 infected people with the coronavirus. Let's go to format options and let's again check everything. So data label, display units. Let's not, display it in the number of case, number of thousands, but just click on none. There you go. These are the raw numbers. And let's put it a little bit smaller. 35 should do. Okay. And let's just change value here to cases. Okay, cool. Now I want to do the same for the number of recovered and deceased. So copy paste this visual. Just, sorry, do it again. All right. There you go. Now I want to filter this visual, only display the recovered numbers. And the third, I want to only display the deceased or the number of deaths. There you go. And again, sorry, display, or change the title. So recovered and deceased. Let's call it deceased. There you go. Okay, great. Now let's change this a little bit so it's closer to the graph. Yeah, like that. Okay, looks good. Now let's change the recovered number with a color. Let's see, how do you do that? Oh, there you go. Okay, the category in the format options. Select the green color that we used for, oh no, that's the, the category itself. Sorry. So we want to change the label here, not something else. Okay. Oh, there you go. Green. Okay, cool. And then for the deceased, do the same. Go to format and select the red. There you go. And whenever we click on a country, so let's say Belgium, see what happens. Okay, seems to be correct. So on the 23rd of March, we had 3,800-ish cases. Around 90 people died and 260 people-ish recovered from the coronavirus. And again, if you hold control, you can just sum different countries. Right, so Netherlands and Belgium. And if you add Italy to that, yeah, a lot of deceased people, as you can imagine. Okay, so this is our first visual. So where we can select one or multiple countries of the top 34 countries in the number of cases here. And we have made some line graphs here. And we use some cards. So this is our first page we made here. Obviously, the one thing I would change here is if you click on table, let's add a title so people know that they can select a specific country. So select country for specific figures or multiple by holding control. All right. Let's put it in the middle here. Okay, it's not very pretty, but it's informative. There you go. So this is your first page on Power BI. Congratulations. Okay, now let's create a second page now, where you can do a country comparison in depth. So this is your general overview page of the spread of the coronavirus globally. Let's call it like that as well. So go to page 1 here, double click on it and type general overview. Okay, neat. Just click on the plus here, a new page. And let's call it country comparison. And we basically want to include on this entire page only countries that are in the top 50 when it comes to the amount of corona cases on the 23rd of March. So we need our ranking here as a filter on the entire page. And second, we also only want to display values starting from the day 100 cases were reported in a given country, right? It's also a way of standardizing the dates. So if in the Netherlands, again, the outbreak starts a week later, their days since 100 cases is just set to 1, just like in Belgium, even if the outbreak in Belgium starts a week earlier, right? So this is a way to standardize the dates. Go to filters, and here we want to add the filters on an entire page. So first of all, go to ranking, drag and drop the filters on this page here. We only want to display on this entire page all the visuals here. Values with ranking, thus countries with a ranking that is less than 51, so the top 50. And apply the filter. Click on apply filter. There you go. And we also want to make sure that we only plot days where at least 100 cases are present in a given country. So let's look here, 100 cases. This is our indicator variable, which is 1 if a certain day has 100 cases in a certain country, or 0 if it is less than that. So filters on this page, okay, add that as well. And say, okay, 100 cases should be 1. There you go. So whatever we plot here, it's only applicable or only apply to the top 50 countries when it comes to their amount of infections. And we also only give values for days that have at least 100 infections. Okay. So let's create a scatter plot here. Scatter plot is whenever you have 2 continuous variables, we basically always want a scatter plot. This is something you probably have seen in your statistics course. Okay, so on our x-axis, let's plot the days since 100 cases. And on your y-axis, let's plot the value. Okay. Again, we see that only 1 dot is plotted. This is because Power BI automatically assumes we want to summarize. We don't want that. We want to display all the days since 100 cases. And similarly, this is also not correct. We don't want to sum all the values on a specific day for all the countries. No, don't summarize. We want it to be that 1 dot represents 1 day in one specific country since 100 cases are reported. You already can see here basically that you have different trends here, that you have basically different lines here. And remember that this makes sense, since if we go back to our data here, since we put this on the x-axis, so days since 100 cases in Algeria, they had 139 cases. Then on day number 2 here, since 100 cases, 201, and then on day 3, 230. But each and every country can have a day number 1 and day number 2, etc. So in Belgium here, we also have a day number 1 since 100 cases where we have 109, then 169, and then 200. And very important here, so this variable standardizes the dates here. It doesn't matter when this took place, right? So we can compare the growth of the coronavirus in each and every country because we have this standardized date variable where we put day number 1 as the day where at least 100 cases in a given country are reported. Okay, cool. Now let's change this a little bit. So go to the format options, and in shapes here, let's change this to let's say minus 21. Okay, looks a little bit better, a little bit less cluttered. Let's change the title, number of cases. Okay, let's put it in the middle. Let's make it a little bit bigger, so 16. Okay, it's a little bit more pretty. Now there's still a filter I have to apply on this graph. Namely, I only want to display the cases, so specifically for this visual, not on the entire page, so drag and drop type on filters on this visual, I only want to display the cases, like that, you see, and not the deaths and the recovered numbers. So okay, cases here. Great. Let's see. Yeah, no summarization. Okay, great. Now, let's change the y-axis title to number of cases. And the x-axis, days since 100 cases. Seems fine. Okay, now add the country or region to your legend. Drag and drop that here. And there you have it. Now, again, only the top 50 countries are displayed here. So you don't have like, I know it's 170, 180-ish countries. No, we only have 50 countries here. Let's copy paste this visual because we want to keep the basic ID here the same. Copy paste it once and then delete the legend, because with legend we don't need this 4 times. It will be the same in any graph, right? So the same color will be applied if you copy paste it. Okay, great. Now let's make this a little bit smaller, because as you can see, it doesn't fit here. Yes. Okay. Okay, great. Let's make it a little bit smaller even. Yeah, this is very nitpicky, but this is where this visualization is all about, because we want some space between the graphs. Okay, this is not perfect, but this will do. Okay, so for our second graph, we want to standardize also the number of cases and not only the date here. So instead of displaying the raw figures of the number of cases, let's delete that on the y-axis and do the number of infections per million inhabitants here. There you go. Let's change immediately this to infections / million inhabitants, sorry. This is one of the variables that I calculated myself based on the information of the number of people living in a certain country, the population size, and the number of cases given by the Johns Hopkins University. Okay, and let's change the title to infections per million. Okay, great. So this is a standardized version of your first visual. Let's check also the deaths per million here. So this, again, delete the y-axis number of cases and do number of deaths per million inhabitants right over here. Again, let's double check that it doesn't, no, don't summarize it ever. No, let's check to be sure. Also on a second graph, don't summarize. Again, be very wary of these functions you apply to the variables here. So make sure you don't summarize anything here. I want to display each and every value for each and every country. Don't summarize. Okay, cool. So these are the number of deaths per million inhabitants in a given country. So let's change the title to disease per million. Move. Now let's do deaths per million. Okay. And on your fourth graph, let's say want to display the deaths versus the number of cases in the previous day. So on your y-axis, again, delete that, and then dead cases previous day. Again, don't summarize anything. There you go. Oh, country, region. Okay. Let's change the title here on your fourth graph. Title is deaths day. That's in a given day, sorry, versus the cases of the previous day ratio. So imagine that in Belgium 200 people are infected and the next day 20 people die. Then 10% of the people who were at risk of dying in a day died the following day. So this would be displayed as a 0.10 dot on the graph. And again, we see how successful the countries are in battling this coronavirus by over time by displaying the days since 100 cases were reported. Okay, great. Now let's do one more graph, and let's do a line graph now. So line chart. Let's click on that. Okay, great. Let's do it a little bit wider, like this. And then again, we want the days since 100 cases on your axis, your x-axis. Don't summarize anything. Okay, great. And then we want to display the growth rate by day. Let's see growth rate one day. So there we go. Values. Okay. Again, yes. We want a legend. Oh, country regions, because right now it just sums all growth rates of all countries. We don't want that. We want to display it separately for each and every country, which makes more sense. There you have it. We don't want the legend, or we do want the legend maybe in our fifth graph. Okay, let's change the title here. So go to format, format, and then title, and then say growth rate cases by day. So right here, again, this is one of my own calculations. I divide the number of cases in a day with the number of cases in the previous day. So imagine that in Belgium you have 200 cases, and the next day it's 400 cases. Then the growth rate will be 2, so 100% extra cases are added in one day, right? So, okay, let's see that we don't take a sum here, or we could take some. Yes, that's okay. Now, we want to filter these graphs, these visuals, so we can make a country by country comparison. So again, you could, in this case, let's display just a slicer here, because we just want to display the countries as such and not extra information like we did in the table here, where we displayed also the cases and the ranking. No, just display the countries as such, and then drag and drop country region into the values box here. Oh, sorry. Okay, weird. Okay, country region. There you have it. And again, we don't need to apply a filter here, because we already applied a filter on the entire page, that we only want to see the top 50 countries when it comes to their number of infected people. Okay. Okay, so let's make this a little bit, yeah, like that. Oh, sorry, like that. And let's change the title to, let's put on a title, let's put this on top 50 infected regions. Let's put it in the middle. Let's make it a little bit bigger. And here in the field, let's change the field to hold control plus click for country comparison. Okay, there you have it. Let's see if this makes sense, if this works. Now let's make it a little bit wider. Okay. Okay, so this should be basically your second page here. Let's click on Belgium. Okay. Okay, this seems correct. So always double check your visuals if they make sense. So on day, what is it, 17, 18, we have almost 4,000 cases. Also, if you hover over this these dots, you can see the specific value. So 3,700, that makes sense. Infections per million tends to rise, that makes sense. Okay, let's hold control and select another country. Let's don't do the Netherlands, but let's do Italy, right? So it's alphabetically ordered here. Look for the I and click on Italy. Okay, you see that Italy is displayed, you can see that in the legend here, in blue. And it has a lot of more days, let's say, where there are at least 100 infected people in that country. And you can see, and this is pretty scary, that we are, it's not that Italy, as if you compare it to Belgium, is on a totally different path. So if you compare the Belgian graph, Belgian dots, the blue, the yellow dots with the blue dots, Italy, you can see we're kind of on the same path as Italy is. When you look at the standardized metrics. So of course you have already more infected people, because it's obvious there are more people living in Italy. But if you look at the number of infections per million, you see that Belgium is actually scoring a little bit worse than Italy right now. And if you look at deaths per million, you see that we're kind of on the same path here as Italy. Although in Italy, let's hope we don't see the let's say the deaths per million that Italy saw, since 100 cases were reported there. So let's hope this levels off here in Belgium like that, right? And I can see the growth rate here. So Belgium and Italy kind of perform the same. So in the beginning, if you have 100 cases reported, the growth rate is very large. So you go from 100 to immediately 400 cases, 1,000 cases, and it kind of levels off as more and more cases are added in your population, are reported in your population, and more days gone by, right? So it levels off the growth rate. Okay, so this is your second page. Congratulations again. Now let's create another page where we focus on interpretation of visuals and testing certain hypotheses. So go to the plus here and let's compare the infections per million inhabitants as of now, so the 23rd of March, the latest date in our data set, and correlate it with some country characteristics such as urban population, how much the government spends on healthcare and all that. So let's call this, for example, correlations. Oh, there you go. Correlations with country characteristics. Okay, there you go. So I want to add some scatter plots again. So let's click on scatter plot here. Okay, and on your there you go. On your x-axis, let's start with the urban population, right? A proportion of people living in urban areas in a specific country. So put that on your x-axis here. Again, don't summarize it. Okay, and then search for the number of infections per million inhabitants. Again, this is one of the calculations I made thanks to the Worldometer data and the Johns Hopkins data combined. Again, don't summarize over here. Okay. Now you can see here that there is some trend visible here. But pretty important is that we only want the status, let's say, of the last day in our data set. So we need to apply a filter on this page here specifically, not only on this visual. So drag and drop day to filters on this page in your filters tab. And just say that you only want to see data for the 23rd of March. There you go. Okay, so this looks okay. There's only one little issue here is that you have obviously some outliers here. So if you go, So if you check these dots here, you can see that there is a country with a lot of infections per million inhabitants and where almost everyone lives in an urban area, 97%. Now, if you want to know what kind of countries you're talking about, and this is also one of the golden tips, let's say, of this workshop, you can put something in the tooltips field. So drag and drop country region in tooltips. And if you do that, then the variable information of country region will be displayed whenever you're hovering over some dots. So for example, we can see here, we're talking about San Marino here, which is a very small country. So of course, even if they have a rather small number of infected people, and even if we standardize this and use this metric, then San Marino will score pretty high even with just a couple of hundred infected. So to take these outliers into account and to basically spread the data a little bit more and to make sure that these outliers have less influence, we can transform the y-axis to a log scale, to an exponential scale. So go to Format and then y-axis, and in scale type, click on log instead of linear and see how the graph changes. There you go. You see that now the y-axis, the increases, or let's say the increase is not linear. So we go from 1 to 10, and then the next step is 200, and then the next step to 1,000, and then 10,000. So this is an exponential scale here. But it makes more sense to plot it in a log scale to view if there's a relationship between these two variables, right? Okay, so now we can hover over each and every point that you can see here, and you can already see that there is probably a relationship here, a positive relationship. So the higher the proportion of people living in urban areas in a given country, the more infections per million inhabitants were reported on the 23rd of March, on our latest date. Now, you can add a trend line to this graph. Just go to the Analytics tab here, which is the first time we use it in this workshop. Click on Trend Line and add a trend line. That's it. And now you have a trend line. Let's dash is fine. You can do a solid trend line or a dash, doesn't matter. Okay, great. Now we want to check whether this is influenced at all by the continent where, of a certain country. So in legend, drag and drop the variable continent in the legend box. There you go. And now we can see the values or the color by continent here. I can see here that probably we could explain its relationship at least partially by the fact that Europe, as you can see here indicated in orange, has a lot of people living in urban areas, and at the same time the number of infections per million inhabitants is rather high. And the question remains, of course, is this a causational thing, or is it just maybe just a coincidence that the outbreak started in Europe, and that at the same time, a lot of people live in urban areas there. So we don't know that for sure. Now let's change these colors to something more obvious. So Africa, let's go to the format tab here, and in Africa, let's give it a brownish color. Asia, yellowish. Europe, let's give it a blue. The European flag or something, whatever is blue. North America, let's give it the red of the American flag. Oceania, let's give it a bluish color, light blue. And South America, let's go for, why not, purple. Okay, this is a little bit more prettier, I guess. Now, we see here that we display the proportion here on the x-axis of the urban population, but we want to display it in percentages. So let's go to transform data again. Let's go to our query editor, and the urban population, population density, urban population, here we go. This variable, let's just multiply it by 100 to display the percentages instead of the proportions. So let's see how we can do that. Let's go to transform, and then standard, multiply. Okay, and then multiply every value here in this column by 100. There you go. This will confuse less people if you display it like that in percentages. Okay, great. Now let's change the title here. Let's change it to infections according to share urban population. There you go. Let's display the legend a little bit larger. Legend. There you go. Okay. So in the format, you can adjust the legend size. And let's rename it to region and not just continent. A region, just like that. Okay, great. Now let's do one more graph. And there are more graphs in my example that I've showed you, but there we go. And let's do the healthcare spending. So copy paste the graph, delete on the x-axis the urban population, and let's go for healthcare spending, government schemes, and compulsory contributory healthcare financing schemes. Okay, x-axis, there you go. Okay, so there's something weird going on here, or not. On the x-axis you see you have values of 200, 250. This is impossible. This is probably because, again, Power BI automatically takes a sum. So again, don't summarize. There you go. This makes more sense. So you can see here again that the more a country spends, or actually the government spends on healthcare, or that the healthcare expenditure is is mostly spent by government schemes, let's say, such as in Belgium, that more cases get reported. Again, let's change the titles here. So x-axis, let's say, government, let's do it without, so government funding of healthcare in percentage of total expenditure of healthcare in said country. There you go. Let's do away with the legend because we don't need that over here. Okay, great. Again, we have a log scale for our number of infections per million inhabitants. This remains valid here. Now, let's check how we could interpret these two graphs here. So let's add a slicer. And let's add the continent here. Okay. Let's go to our formatting options and let's see, go to items and display the items a little bit bigger. Okay, and the title. Let's go select regions for specific figures. Okay, do it a little bit bigger. Let's put it in the middle. No, let's not put it in the middle. Like that. Okay. And then instead of continent here, the fields, let's just put some underscores like that. Now by selecting certain continents here, or one continent, you could do some interesting comparisons and see how the relationship changes here. So you can obviously see that European countries tend to spend, or like governments tend to spend a lot of on healthcare. In Africa, not so much. So the question remains, for example, is this relationship still visible when we look within specific continents? So let's check Africa, for example. We can see here that within Africa, or even within Africa, we can clearly see that the more a government spends on healthcare, the more cases are reported. So again, thanks to the fact that we added here the tooltips, in the tooltips, the specific country or region in that field, we can hover over the dots and just see what countries we're talking about. So here, Seychelles, I guess, spends a lot on healthcare, also reports a lot of cases per million inhabitants. Same goes for Cabo Verde, Rwanda, Algeria, Tunisia, Mauritius, etc. South Africa. Okay. Now, there are multiple explanations for this. So, for one thing, maybe countries that tend to spend, or their government spends a lot on healthcare. They are maybe more rich countries. They maybe have more tourism. I think, Turkey, for example. And because there's a lot of tourism, there are a lot of people passing through. And because of that factor, the odds of a disease spreading is just higher. So maybe it has nothing to do with the healthcare expenditure. Maybe this healthcare expenditure is related to, for example, amount of tourism and there's a spread of the virus because of that. But still, it could be the case that some countries here, such as, let's take a look at here, Sudan, Chad, Uganda, Nigeria, that they maybe underreport some cases here, so that maybe the coronavirus is spreading there, but because of the fact that the government doesn't spend a lot of money in healthcare, proportion-wise, compared to the total expenditure on healthcare in that country, maybe that could explain the underrepresentation here. So it could be a scary graph. It depends on how you look at it. Now, a second comment here is that the trend line here reported is not very indicative of the real trend here. So although it looks as if there's a very clear positive relationship, we can see that the residuals, so basically the distance between a specific case here, specific dot, and our trend line, as you can see here, is not very normally distributed around the graph. You can see that if you just think away of the trend line, let's do that away here in analytics, you can see that the relationship is less obvious now, right? But still, it seems that there is some kind of relationship here. Maybe not linear, but there is some positive relationship between the government spending a lot in healthcare and the infections per million inhabitants reported. Now the question remains: why is that so? Is that a real relationship, or is it because cases are underreported, or because healthcare expenditure is related to, for example, the tourism in said country, and thus related to the odds of spreading the disease? Okay. I could create some more graphs, but I will leave it at that. We will just create now one additional page where we will use some or exploit some bar charts. Okay, so let's do a final page here. And add another page, and let's call it, for example, spread virus continents. There you go. Okay, we want to display on this page how the spread of the virus has evolved when it comes to the distribution of cases between Asia, Europe, North America, Africa, etc. It's a good idea to maybe start with a stacked bar chart here. A stacked bar chart is a good idea whenever you want to display the distribution of a certain variable here. So let's put the value here in the value box right over there. Okay, you can already see that the value displays a bar of 100%. So whatever the value is here, it represents 100%. And we can divide this 100% in different slices according to the legend that you add to the bar chart. So let's drag and drop continent here and drop it in the legend. There you go. I'll go to format, and there you go. Click on data labels. Maybe enlarge it a little bit. It's not possible. Fine. Okay. There you go. Well, you can see that right now, as of today, about 80% of the cases were seen in Asia and around 20 in Europe. Now, what this graph does here is it plots all the values, which is actually wrong. We want to only plot, remember, the cases here, and not the diseased and not the recovered cases. So apply a filter to this visual by going to type, drag and drop type into the filters on this visual, tab, and click on cases. There you go. There's a slight difference. Oh, there you go. Now you might think that intuitively this is not a correct graph, because if we sum, and this is what we do here, so let's check the function of the variable value, sum. If we sum all the values over all continents, we basically count a lot of people 2, 3, 4, 5, even 20 times in the same data set. Because imagine that in Belgium, let's take the Wrangel data set here. So we have the cases on the 5th of March here. And on the 6th of March, the 50 cases become 109 cases. But these 50 people are probably not, or in any way, not all of them are recovered. So these 50 people are probably also present in the 109 here in the next day, right? And same thing for the next day. So 7th of March, 169 people are infected. These 109 people are probably included for the most part, unless they're recovered or dead, in the figure 169, right? So intuitively, you might think that this graph is wrong, but it's actually correct. So you're right if it's about, displaying a specific absolute number. So let's, for example, click on card here, and let's display again the sum of the value, and we only want to see the cases. So filters on this visual again, drag and drop the type, cases. Well, if we sum all values over here, and you can see value sum, then we have 6 million people. Of course, not 6 million people are actually infected with COVID-19 around the globe. But we get this figure because we count these people 2, 3, 4, whatever, even 60 times basically into the same figure here, right? But however, because each and every country has 62 lines, so we have the same number of days for all countries. In that case, the absolute number doesn't match, isn't correct, but the distribution stays the same. All right, so we could calculate a different data set where we have just summed by continent the number of cases for every day, but it would mean, the same. You would get the same graph, right? So okay, this seems fine. Let's see. Let's change the data color. So let's put a brownish color for Africa, Asia, kind of yellowish. Europe, there you go, blue. North America, red. Oceania, bluish, light blue. And South America, purple. Okay, let's make the legend a little bit larger. Hold on a sec, legend, there you go. Okay, great. Now let's change the title to share of cases by region. Let's make it a little bit larger and put it right over there, like that. Okay, great. Now let's create another chart here. So let's go for a donut chart, which is basically just a fancy version of a classic pie chart. Oh, hold on. Yes, okay. And again, drop the value in the values fields. There you go. And the type in legend. And we only want to display the proportion or distribution of the deceased people here. So again, for type, filters on as visual, select the deaths, the number of deceased people, and do this by continent. So drag and drop continent and put it, oh, that was wrong, sorry. Don't put type in the legend, but continent. There you go. Now let's disable the legend here. There you go. The labels are fine. Let's make them somewhat bigger. Okay. Now the legend is off. The title, let's say share of deceased by continent. There you go. Okay, that looks somewhat fine. Then the colors again. Asia, Europe, North America, Africa, South America. Oh, South America was like that, yeah, and Oceania. Okay. So around 70% of the deceased people are also being mourned, let's say, in Asia. And now let's make a regular bar chart here, so a stacked column chart, for example. Let's click on that. And let's display on the x-axis the region. So axis region. And let's display the growth rate from 1 day. So again, this is the number of cases in 1 day divided by the number of cases in the previous day, right? So a growth rate of 1.4 means that the number of cases has grown with 40% in 1 day, right? So let's put it over here. Now, of course, a sum is not meaningful here. So let's do an average. So the average growth rate. Let's not do it by country because I can see now there are a lot of countries here. Let's just do it by continent. So replace the axis, do away with country and put region with continent here. There you go. This makes more sense. Okay, you can see that the growth rate in Asia, the average growth rate, was is pretty spectacular in general. And then comes Europe, and then last Africa. So the disease proportionally speaking, tends to not spread as fast as in other continents in Africa, right? In Africa, it's a rather slow pace, let's say, that it grows. Now the data colors again. Data. Hold on. Oh yeah, right. So if you want some data colors here, we have to add it to our legend. That's right. So let's also add the continent to our legend here. There we go. And then just go to Format and disable the legend, but then go to Data Colors and adjust the colors. So Asia, yellow, again, you know the drill. South America, North America, and Africa. Okay, neat. Let's change the title as well. So again, in the middle, let's do it a little bit bigger. And let's say average growth rate infected by continent. I also see now that I have the wrong variable here. It's not the, or is it? Yeah, sorry, it is. No, it's not the proportion of the growth rate. Sorry, it's just growth rate one day. Okay, getting kind of confused here. There you go. And again, take an average. Okay, the story somewhat stays the same here. So Asia, very fast spread of the virus. Africa, not so much, rather slow, proportionally speaking, or relatively speaking, with the numbers present. Okay, so now let's add a slicer. Okay, great. And put date there. Right, so date, drag and drop it in the field. And right now we can adjust. Let's put a title there as well. So select date range to change period and study. Let's put a space here. Okay, there you go. And now we can adjust the date range in any way we like, and we get some different numbers. For example, here, let's check the beginning of the spread of the virus. It was all Asia, and then we can see 24th, etc. And Europe starts to, share its number of deceased as well, and especially number of cases, right? And this will probably grow and grow. The proportion of total cases that come from Europe will grow and grow, and probably also from the United States as well. Let's do one thing before we close here. Let's change here the data labels of this bar chart here. Let's put them on. There we go. Let's put them inside end. There we go. This looks pretty good, right? So now we can see how the virus spreads over time, and also what the growth rate is of each and every continent given a specific time frame, right? Okay, so this is your already 4th page on Power BI. Congratulations. And I think this will be plenty to start with, right? Now, what are some of the key tips and tricks here and that I provided you with? First of all, filtering visuals and even entire pages is something you always have to keep in mind. What am I displaying here? What do I want to display? It was pretty obvious from the exercise we just performed. Second of all, melting data or unpivoting data, and at the same time filtering is one of the key insights I provided you with. So if you want to plot a certain variable and you want to apply want to split it according to a certain group, melting your data so you have one column for all the values, even if they mean something else, is something key here, right? And next to that, you have a variable that contains the labels or the category. Remember that we had one column with all the values in our exercise here, and that we just divided these values according to the categories cases, deceased, and recovered, remember? Third key tip and trick here is copy pasting your data set, doing some operations such as a group by or performing some functions, filtering, etc. Or as we did, we added an index variable to our copy-pasted data set to add a ranking to our countries when it comes to the number of cases they have. And then join it with your general data set is also something that you have to keep in mind, right? So always keep in mind that you maybe have to do some wrangling and joining, merging before actually doing your analysis or while you're doing your analysis. And fourth, and also very important, be aware of the function you're applying to any variable. So are you displaying a sum, an average, a minimum, or maximum? And above all, what does it mean if you display a sum versus a maximum? That is also something I try to put some emphasis on throughout this exercise. Okay, and that's it. So I hope this was somewhat fun for you. If you have any questions, of course, do not hesitate to contact me. You know my email, or you know how to contact me with live Q&A sessions. I wish you all a very pleasant and healthy, let's say, day, and I'll see you all later. Bye now.